Hi everybody and welcome. Today we're going to be taking a look at slope and parallel and perpendicular lines. So we have a couple goals after watching this video. So your first goal is to be able to understand slope in context and on a graph. Second goal is to be able to understand when two lines are parallel based off of their slope. And then your third goal is to be able to understand when lines are perpendicular, also based off of their slope. So first, as always, starting off with a real-life example. So this is at an ice cream shop called Clown Cone that I went to with my wife, and when I saw this, I immediately thought of slope, and I was like, I need to take a picture of this to be able to save it and to use as a real example here. So you might notice here, for one scoop of ice cream, or one dip as they're calling it here, it's $1.75. For two dips, it's $3, and for three dips, it's $4.25. So if we take a look, one scoop of ice cream is $1.75, so you're thinking, okay, two scoops might be twice the price. If you were to do 175 times 2, you're going to find out, well, that's not $3. You'd actually be expecting to pay a little bit more, like 50 cents more. So after today, we're going to take a look back at this, and we're going to see, is this ice cream cone shop, is the person that determined pricing here, are they using any sort of logic, or is it just kind of random how scoops 2 and 3, how they added those prices there? You might be able to see it now, but regardless, after looking at today's video, we're definitely going to be able to interpret this in context and to be able to interpret ice cream actually in the context of slope. So to start off, we're going to define the slope. That's our important starting point. So a common definition. You've probably seen this before in a couple different contexts, but in geometry, we're going to take it to that next step. So slope is the word, and we define it as the measure of how steep a line is. Personally, I think of slope, you probably are the most familiar with this in terms of rise over run. I really like using arrows for this because we can see like the left, right, and the up and down. So, if we're on a graph and we have a line, and I'll do this in a different color, maybe yellow is not the best. If we're trying to measure rise over run here, we're going to see it's going to go up, that's the rise, and then the over is the run. So we could measure that as the distance from the point from there over to there. Our formal definition of slope, we use m to represent it. And we do y2 minus y1 over x2 minus x1. So this is a definition you're going to want to save. We're definitely going to be using this quite a bit going forward. So with that being said, let's start off. So first we want to label x1 and y1. And then second, we're going to label x2 and y2. So if we have an ordered pair, again, just like we've been doing for the distance and midpoint formulas, always want to start off by labeling those points. Super important. Third, after doing that, we're going to subtract our two y values, so we'll have y2 minus y1. Fourth, we'll subtract the x values, so we'll have x2 minus x1. And then finally, we're going to divide the difference in our y's over the difference in our x's. So it's just a lot of different steps and a lot of different ways to say that after we have x1 and y1 and x2 and y2, we go through, we follow the formula, and we fully calculate. All right, so on to our next one here. So again, another way to say slope is it's a ratio of a line's vertical, so up or down, rise, to its horizontal, or left to right, run. And again, that definition, which is super important, we have y2 minus y1 over x2 minus x1. And this is an example, the order does matter. So with that being said, let's take a look. We have an example here. We have two ordered pairs. So on top, we'll start off with x1 and y1. And on the bottom, we'll have x2 and y2. So those are clearly labeled, and we are ready to plug those in. And also just to be extra clear, that's our x term. And that's our second x term. And let's highlight those y terms. That's our y term, and that's our second y term. So now that we have both of these, time to put them together and to compare and evaluate. So in our formula, we start off with y2. We subtract y1 all over x2 minus x1. So carefully labeling this, and then now I'm ready to plug in some numbers. So y2 is on the bottom, which is -2. Y1 on the top there is +2. x2, we have that as -3. And x1, we have that as -1. Okay, so I followed my formula, I plugged in carefully, I have my x's in the right spot and in the right order. Same thing for the y's, so now I'm ready to go through and do some order of operations and basically just to evaluate. So minus 2, negative 2 minus 2, it's going to be negative 4, and then divided by, on the bottom, negative 3 minus negative 1 is going to be negative 2. So we have negative 4 over negative 2 as our slope. Negative 4 divided by negative 2 gets us positive 2 as our overall answer there. So finding the slope for example 1, we did it. We went through carefully again plugging into the formula, and we found that slope of positive 2. The biggest thing with these is making sure we don't get x's and y's reversed. And the second biggest thing is being very careful with negatives, especially you can see on the bottom here, if we are subtracting a negative number, that's a huge place that is super important to use parentheses. So be careful with negatives, be careful with x's and y's. If we are annotating and going through carefully, we'll be in really good shape. So do the same thing that I did for the remaining questions on this slope page. And now we're going to actually turn over to our next example, which might be a little bit new. So hopefully slope was a bit of a review for some of us. Our next example might be a little bit new. I did cover this in my Algebra 1 class last year, but I know that not all Algebra 1 teachers get to this. So our next definition is perpendicular. And the definition of perpendicular is lines that intersect at a 90-degree angle. So it's just a really fancy way of saying if you have two lines and they cross, and their crossing happens at a 90-degree angle, they're perpendicular. Now, the tricky thing is when we're looking at this just based off a slope, if you have a slope of 2, a perpendicular slope to 2, how do we find that? So the way that we do it is we call it the inverse reciprocal. It's just a really fancy way of saying we flip the number and we flip the sign. So here we have positive 2 over 1. And again, if you have just a number, you can always put over 1 as a fraction there. So if we're flipping everything about this, we're going to change it to 1 over 2, and we're also going to make it negative. So that's just one example. A second example, so we can see this a couple of times here, is if we have something like negative 3 over 5, our inverse reciprocal, or a perpendicular slope to negative 3 over 5, would be positive 5 over 3. So again, we're flipping it and we're changing the sign. So two examples of perpendicular slopes, and we're going to be able to see that in some examples coming up next. So the first thing that we want to do on this top question is it's asking us to find the slopes of L, M, and N. So start off with N, and I'll highlight N so we can see where we're working. Okay. And these points are kind of a mess. So let's see. So the point that we have right here on line N, this point is 4 over 2. The other point that we have here on line N is 1 comma negative 3. So for line N, let's go ahead and label this. I want to be really careful with my annotations here. And in a different color, let's label. So we have x1, y1, x2, and y2. And now we're ready to plug in. And again, you'll notice I'm taking extreme care and extreme caution to make sure I'm not messing up any negatives. I want to be very careful going through and calculating these. All right, so it looks like we have negative 5 over negative 3. Or we can just call that 5 over 3. So that's our slope for N. All right, let's move on to another line. We'll take a look and we'll highlight it. Line L. And you know what, maybe I should do that in a different color so we know that line L is a different line here. So I'll do that in blue. In line L, we see this point right here, and we also see this point. So 2 points on line L. We have negative 3 comma 5, and we also have 2 comma 2. So again, let's go through. x1, y1, x2 and y2. And we'll take a look just like we set up before. So 2 minus 5 over 2 minus negative 3. And again, being careful, plugging in with parentheses here. So we're left with negative 3 over positive 5 for line L. Okay, so we have two slopes calculated, and let's go into our last one now. And this might get a little bit messy because I know that we're very close to line M and N, but let's take a look at line M. All right. And we just got kicked out here, and that's okay. Sorry about that, everyone. All right, so we're back. So we have 1 point here and a second point here. So for line M, 0, 4, and 5, 1. And again, doing this in a different color. We have x1, y1, x2, and y2. And again, going through and plugging these in. y2 minus y1 over x2 minus x1. We'll get negative 3 over positive 5 again. Okay, so we have three slopes for three different lines. And again, let's highlight these so we can see three different slopes for three different lines. So here is one slope, here's a second slope, here's a third slope. Okay, so we just talked about perpendicular lines, so now let's see some definitions of some things that we may or may not know. So if two lines have the same slope, they are parallel. So let's take a look here. Do we have any slopes that are the same? So it looks like line L and line M are both negative 3 over 5 for slope. So they are actually parallel. I don't know why it keeps kicking me out, but we'll keep going with it. So again, line L and line M, same exact slope, they're parallel. That's one clear example there. All right, so two non-vertical lines are perpendicular. So again, remember that means intersect at a 90-degree angle if the product of their slopes is -1. Well, remember up top we talked about the inverse reciprocal, so it's flipped and the sign is opposite. So if you look at line N and line L, we have a slope of 5 over 3 and -3 over 5. Well, that looks to me like we flipped it and we have the negative sign, but let's test this definition. If we multiply them, do we get -1? So negative 15 over 15. That's also a way to say that it's -1. Okay, that's awesome. So N and L, these are perpendicular. They intersect at a right angle there. And we can say here up top that L is parallel to M. All right. You might also note that because line M has the same slope as line L, we can also say that N is also perpendicular to line M. So both of these intersect at a right angle. And if we look here on our graph, we do see that, yes, these are intersecting at a right angle. So they do cross exactly there. All right. So some examples, the big thing for this one is that we had to first calculate slope, and after we did, we can compare our slopes and we can see, are they parallel, are they perpendicular? And that's going to help us to determine what's the relationship between these lines. And they might not be either, but the important thing to remember is using those definitions, compare those slopes, and again, inverse reciprocal, or if we flip it and we flip the sign, that's going to be the quickest and easiest way to see if we have perpendicular lines. All right, so let's finish up those practice questions on this page. Any questions, as always, feel free to reach out. And thanks for tuning in, everybody.